it's good afternoon now. My name is Kelvin Franklin. I'm Senior Manager, Product Specialist for Ethernet Fabrics. And so I will be talking to you today about Ethernet Fabric technology. And you're going to see a common theme across the different product sets. My technology focuses on the data center. I hope a lot of you have seen the announcements we had at Tech Day around what we're doing in the whole Ethernet Fabric space. I'm trying to make sure that this is the only marketing slide that you see. Hopefully we'll be able to get into some good discussion. And I also have engineering here to keep me honest. And so anything that I say and you're not sure on, look back there and he'll either do this or he'll do, oh yeah, or I'll get that, that type of look from him. So yeah, I wanted to see if this thing is working. But great, so here's my agenda. I want to get into talking about fabric-based Ethernet and what that is all about. Then I'll get into Brocade's Ethernet Fabric technology, talk about what's coming, where all of this is going, and then also give you an idea of some of the ways that we see our customers using this technology. So that usually facilitates a lot of questions. Looks good? All right, good. So let's take a few steps back. Before we even start talking about Ethernet fabrics, often when you're releasing a new technology to the market, some of what you're trying to achieve or what you're trying to do from a depth standpoint gets lost, especially in marketing. They like little short blurbs, and they send those out, and you lose some of the subtlety that we're trying to achieve with this technology. And so I wanted to first start off by talking about what a fabric is. A fabric is a high-performance, reliable, connectionless interconnect. So that's what a fabric is. And for you guys who've been in tech for a long time, if you think about other types of interconnects, such as InfiniBand or fiber channels, where it's about making sure you have this underlying framework that you can use as a reliable transport for the upper layer things that are going on. So a fabric inherently is a high-performance interconnect network that's very reliable, regardless of the protocols that you're going to run on top. And so the reason why I say this is because if you start looking at what we're saying an Ethernet fabric is, inherently Ethernet isn't that way. Ethernet does not work that way. Ethernet is, some people may say it's reliable. It's not as reliable as technologies like InfiniBand or technologies like fiber channel. You have high performance there, but for the types of things that our customers are doing within their data centers today, they need the same type of functionality they would traditionally find in InfiniBand or fiber channel in an Ethernet network. And so when we started talking about doing this technology, that's what we wanted to achieve. We wanted you to be able to have an Ethernet network and be able to have the same type of reliability, scalability, low latency that you would find in these other interconnect types of technologies. Any questions? Any questions about that? And so what we want to do also here from an Ethernet fabric standpoint is allow you to have the same type of switch operation that you'd find per se in a SAN network, where the switches can make forwarding decisions independently. They have a full concept of the whole topology. They don't have to depend on anyone else if there's some type of outage or there's some type of loss, a lost link. The switches can forward the traffic regardless, so long as there's redundant paths in the network. And then when you think about things like layer 2 and layer 3, those are services that you overlay on top of this high performance interconnect. And so our first instantiation of this was when we shipped this fabric technology. So when we first shipped this Ethernet fabric technology, the first service we had was a layer 2 service. Now, with our latest announcement, you hear NOS 3.0, where we just announced that we're supporting layer 3 on top of this high-performance interconnect, which we call Ethernet Fabric. I actually think the name would have been better if it was fabric-based Ethernet, because then if you understand what a fabric traditionally does, then you're seeing that what we're doing is trying to make Ethernet operate in the same way or fashion. So this is also what we're announcing today from me. This is our first announcement of service-oriented fabrics. And so what we're saying here now is just like there's layer 2 and there's layer 3 services that we're supporting on the fabric. Moving forward in the future, there will be additional services that we will support on top of the fabric. And I'll get into more of that as we talk about the roadmap. Right?
Okay, so you say the layer 2 and layer 3 protocols are services that run on top of the fabric. So the fabric itself is not built by manipulating the layer 2 tables at all.
So the fabric, yeah, is not built by manipulating layer 2 or 3 tables at all. The fabric is built using underlying mechanisms like Trail in the fabric in order for you to build a full topology. And then if you want to start doing point-to-point or point-to-multi-point layer 2 communication across it, you can do that. Or if you want to turn on layer 3 functionality anywhere in the fabric, you can do that. And so this gives you a lot more flexibility and a lot more scalability. And so that's our view of how fabric should be. We don't believe in a concept of IP-based fabrics. If you have an IP-based fabric, then when you want to do layer 2, how do you do it? You have to look at some other way of doing it, like VXLAN. You have to look at some other protocol that allows you to encapsulate layer 2 within layer 3. And for us, that adds a lot more complexity to the story. How about we just allow you to do layer 2 where you want to do it, or layer 3 where you want to do it, and then following on with other types of service in the future that allow you to do other types of things within the fabric. Make sense? Mm-hmm. Okay, good. This thing's not working very well. So now I'm having my my issues. You did this to me. Okay, let's go back here. Okay. So our fabric technology is called Brocade's Virtual Cluster Switching, so VCS fabrics. What we focus on with our technology, with our Ethernet fabric, is non-stop networking. Like I said, that first component, reliable interconnect. Then, on top of that, and everything we're doing, we want to make sure that we're not adding any additional complexity to your network, and we're also allowing you to automate wherever possible. And I'll talk about some of that automation.
So you talk about bringing your baseline fabric up to the levels of availability, and assuming buffer control and availability that you have in your fiber channel and FinBand fabrics. When you say nonstop networking, are you guaranteeing that a frame will not get dropped?
I can't guarantee that a frame will not get dropped, but I'm going to give you as close as an environment from the Ethernet side that you would find on the SAN as possible. And so what we're trying to design a network here is, if there is drop frames, it's going to be a very limited number. I can't promise that there'll never be any frames dropped, but because we have that inherent intellectual property coming from that side of the house, we leverage a lot of that and bring it in over to the Ethernet side, and that allows us to be very successful at deploying lossless Ethernet types of fabric. And I do quote lossless. And the other thing here, and I think it's a big key, is the evolutionary nature of this. I think one of the keys to any new technology that you're going to deploy in a network is you give people a migration story. You cannot say that, you know what, the way you did things in the past, all of that needs to change. You need to rip out everything, and you need to start with this very expensive Ethernet fabric in order to roll out this new technology. What we want to do, and what has been really receptive from a lot of the customers I talk to, is we can give you a small fabric that you can start with, that you can implement in your network. It'll interoperate with all of the traditional layers that you have in your network. It'll look similar to what you're used to, and you can start testing out the benefits of an Ethernet fabric, then grow from there. So you can evolve yourself into the fabric. And if you think about it, a lot of this is based around 10 gigabit Ethernet technology at the base of it, then growing to 40 gig and 100 gig in the future. Not many of my customers are going to swap out hundreds of 1 gig servers they have in and implement 10 gig on all those different servers. They're going to swap out some of those servers. They're going to start rolling out some 10 gig and putting 40 gig in where it's needed. So this is a nice migration story with a lower upfront cost to get into the Ethernet fabric technology. And so let's look at what we were talking about. How do we build this fabric? What is this fabric? How do we make this fabric work? And so if you look at what we're doing at layer 1, first of all, we have something called Brocade trunking. Brocade trunking, if you're familiar with our storage area network switches, it comes over from that side. We have it now on the Ethernet side, where the actual load balancing is done in the ASICs, in the hardware. So what we're actually doing is packet spraying across the ISLs in between the switches. And so we get more efficient distribution of the packets across your ISLs. Think about how this would be done in traditional products. If you're doing load balancing, you're usually doing flow-based load balancing across your ISLs. If you're doing flow-based ISLs, you may have a likelihood of all of your flows going down a single ISL, or majority of your flows going down a single ISL or multiple ISLs. You're not efficiently using your bandwidth between your switches. And those are expensive ISLs because it's 10 gig ports. So what we do actually is packet spraying, and the hashing algorithm that we're using is based on a 7-tuple lookup for those protocols that support that. So 7 tuples would be your source and destination MAC, your source and destination IP, source and destination port, TOS, that type of information. We're less likely to run into a hash collision, so now we can efficiently spray the traffic across those ISLs. When you talk about, okay, how do we make it more lossless, is these types of things that help with that, so we can avoid congestion on the ISLs themselves, and that way,
I mean, congestion is a reality in any fabric.
right, it is a reality, but
What do you do when you encounter it?
right, how do you handle it? And so, but first, you can also do some proactive types of things, because in traditional Ethernet networks, you run into flow type issues very easily. And so if you can get around some of those flow type issues, it makes it easier for you to deal with those congestion issues that will come up. And so our Ethernet fabric, of course, supports DCB, and you can start using DCB in order to prioritize certain traffic over other traffic within the network, and then pause specific lanes of traffic so that priority traffic can still get through.
So a flow still would go down a single link because you base your decision on that 7-tuple value?
No, the flow is actually going to be sprayed
Okay,
across.
so the flow itself is sprayed.
Sprayed across. And so we're putting on, getting into a little detail here, we're putting on an additional header on it,
Okay.
so that we can actually disassemble the flow and then put the flow back together on the other end.
Takes
So-
notes good, by the way.
Okay.
Don't worry.
I was
So-
worried
so-
about how much trouble I'll get
Yeah,
into.
so what's the purpose of looking at the 7-tuple, or bringing up the 7-tuple?
So that comes into when you're looking at how you're going to do your equal cost multipathing across the network. And you're going to look at, okay, what paths do I have available and how am I going to spread these different flows across the entire network? So the ISLs themselves have this frame striping capability and packet spraying capability. And then to get a flow end to end across the fabric, you have this ability to look at the flows and do this hashing in a more efficient manner. So it's less about the ISL and more about the whole the fabric as a whole. And
So
how
for
you can
devices
flow
that couldn't reassemble or reorder your
Right.
packets.
Right.
So you look at Trill to spread it across multiple link groups, and if that link group itself had multiple physical links, not trying to sell the spray and pray across your three or four links.
So, sorry,
So
repeat that?
You'd have your higher level protocols, load balancing across logical links.
Right,
And then when you get down to your individual trunks.
right. So you get down to individual trunks and you start spraying
Spraying.
across. Exactly.
Okay.
Yes.
Okay.
And so, and the other thing here is layer 3. So layer 1 with the trunking, layer 2 with Trill, layer 3. So if you turn on the layer 3 services, we actually allow you to turn on the layer 3 service across multiple different switches within the Ethernet fabric, and then we'll load balance across those multiple switches. If you have servers down here that are connecting to their default gateway, they see one default gateway. They still see one default gateway, and the fabric itself is intelligent enough to handle the flows going across, making sure they're load balanced across. And on the other side, if you're connecting to your layer 3 core, the core today will see multiple instances of OSPF, for example, because I know you had a question like that earlier. The most important thing is here, now you have a more scalable layer 3 mechanism that you can overlay on top of the fabric.
So another networking vendor that's not Cisco introduced a Ethernet fabric, and in my opinion, how they entered in layer 3 into it, it would suck all the traffic to one side and bring it down. How are you actually managing? If I'm scaling out my layer 3 gateways based on need traffic or the needs of my traffic, how are you managing that horizontal scale out of your layer 3 services?
So from a management standpoint, are you saying how are we distributing it? How are we making sure it's efficient? Or
Yeah, I mean, there's obviously other. I'm trying to put a nice way to put it. Other network manufacturers that aren't Cisco failed in this endeavor.
so
Miserable.
engineering stood up. I'm going to let them handle this question.
So, with
talk, I think you discussed the gateway aspect.
Yeah.
So the gateway aspect is by adding more gateways, we can actually give you better redundancy.
Yeah.
We also talked about the different layers to get different distributions. So in terms of how routing can be turned on, it totally depends on your use case. So if you turn on routing on any one node inside the fabric,
Yeah.
technically you have enabled the routing service on the VCS fabric. It is a router. The entire VCS fabric is a router. Now, if you want to make your routing available, highly available, what you can do is you can turn it on multiple nodes,
Yeah.
and that way you will have your redundancy from every perspective. Another thing you can do by turning it on multiple nodes is you can get your L3 CMP going through the fabric, which is the third aspect towards the core.
Yeah.
So these are the ways that you can turn on your routing. So you have to manage your routing towards the core if it's a different vendor in
Yeah.
such a way that you're actually importing all the routes into your VCS layer so that it is the same in each of the switches, because they need to have a consistent view towards them.
Yeah.
So that is the responsibility of the admin.
I mean, one use case is you have multiple L3 domains in your data center, in your fabric, and you're pushing, you have top of rack switching distributed all through, right? And host from subnet A needs to talk to subnet B. They're in the same rack, right? Should they get sucked all the way across the fabric, or should they be, no matter when you instantiated L3 services in your fabric, be able to take that shortest path? And now, are you saying that no matter if I instantiate an L3 service, that I can provide that VLAN to VLAN routing across any single switch in my fabric?
So you could instantiate the layer 3 service and have it done at the switches.
So the
and
beauty of the
top-
solution is it's up to the
yeah,
admin.
admin.
So for you, for example, if you feel that it's important for you to do your routing at the closest hop towards the server, because maybe latency is very important for you,
Yeah.
you can turn it on actually on the access talks. We
Yeah.
actually support
Yeah.
that. But if you feel that I don't mind if the packet goes all the way towards the aggregation box and it can come back, you can actually turn it on over there.
And it would be presented as the single L3 address that would be consistent across all of them.
Yes, what you would
Yes.
normally do is you'd have 4 spine switches
Yeah.
and then 20 leaf switches.
Mhm.
And you have 4 spines actually doing the layer 3 routing for the fabric.
Yeah, no, I understand best practice on, but there's some weird corner cases out there
Oh yeah,
that.
sure. So the long-term future for the chipset and the software is to do layer 3 on all 24.
Yeah.
Right. So I think conceptually, if you forget about the physical layout of all the switches, right, for a given VLAN, because that's how you're going to turn on routing, right, everything will look like they're on the same LAN. So logically, they will all look like they're on the same shared LAN. So if I say in this example where he has 6 boxes, right, if I turn on routing on the lower leftmost and, if you can do that.
Sorry.
Right,
Right.
the lower leftmost and the one on the extreme right, for whatever reason, right?
Yeah.
Logically, it's going to look like 2 routers on a stick. Basically, think of the LAN and you'll have 2 boxes. That's how it's going to look. Even though physically, they will
Yeah.
be looking like they're on different nodes,
Mhm.
right? So that's the beauty of the architecture, as far as how the topology gets presented from a layer 3 perspective.
It's about giving that flexibility to the admin, decide how they should do this, implement this service, the routing service, into the network.
So unlike the other guys, we did not change the routing model as such.
So, no presentation would be good without some good sexy boxes to show you. And so what we have here is our family of products. We've been shipping this technology for over 18 months. You've already heard about the VDX 6710s, which is our 1U 48-port 1 gig with 10 gig uplinks. We have our 6720s, which are 24-port 10 gig and 60-port 10 gig devices. And we have our 6730s, which are 24-port with fiber channel connectivity and a 60-port with fiber channel connectivity. So if you wanted to connect into an existing fiber channel network, you can do that from the 6730 devices. What we've announced recently are our 8770s. Those are our chassis-based VDX products. This allows you to scale at a very high level, giving you, and I'll talk about some of the details in the coming slides, upwards of 384 ports of 10 gig or 96 ports of 40 gig in the chassis.
My box is right there.
Oh, thank you. There's the box.
It's even better than a slide.
Yeah, it's even better than a slide. And so what's important to know also too is the ASICs that are in this these boxes are not ASICs we just thought about. They're actually coming over from the SAN side, so it's a new generation of ASICs based on our SAN technology. And from a routing standpoint, we're marrying our carrier class routing code into the platform. So if you're familiar with our flagship router, the MLXE, which is the NetIron code set, which is in a lot of the internet exchange points around the world, that's a subset of that routing code. It's coming over to this family so that you have a robust routing platform included with this Ethernet fabric technology. From a cloud standpoint, this is for cloud environments that require to be able to scale bandwidth very quickly. So plug it in, and the fabric uses it. Fabric's very intelligent. You don't have to worry about going in and saying, this is an ISL port, or this is an access port. You plug it in between two switches, and switches go, hey, this is an ISL. I'll use that bandwidth automatically with all those mechanisms I talked about earlier. Ultra low latency. So you'll see some of the numbers on the coming slides. 3.6 microseconds of latency, any port to any port on the chassis there. Power is a big deal here. We'll see anywhere from 20 to 30% saving on power for a lot of data centers. That's a big deal because you're paying for that power for these devices in your network. So if we can reduce the amount of power consumption that you have, that you're using in your data center, that's a really good thing. So we're hearing a lot of customers talk about, yeah, thank you for helping me to make it easier to go to the guy that's signing the checks and say, look, we're going to reduce the power but increase the bandwidth, the capacity we have. And then, you know, of course, we're going to support whatever type of storage you're going to use within your network. One of the use cases I'm going to show you is around that high-performance storage type of network. A lot of the customers I'm talking to today are building these high-performance Ethernet-attached storage networks. And because we're one of the leading storage vendors, they come to us to say, help us to build this. You helped us in the past to build these great fiber channel networks. Help me to build an Ethernet-attached storage network. Whether it be iSCSI-based, fiber channel over Ethernet, NAS-based, help me to build it out using the same type of technology you've used in the past. Any questions here? Easy group right now. So this is the chassis right here. It's better than looking up there. So yeah, the chassis ports up to 384 ports of 10 gig today, 96 ports of 40 gig. We've designed this such that you can scale out to over 8,000 ports within your Ethernet fabric. Today there's a 4 slot, that's the 8 slot, and in the future there will be a 16 slot chassis. I talked about 1, 10, 40 gig. It has the capacity to support 100 gig capabilities in the platform, up to 4 terabits per slot. The capacity is there so we can scale this platform. We're building it for a 10-year life cycle, if possible, so that you can put this chassis in place and be able to grow as time goes by, as your network needs increase.
So, so you had 96 ports of 40 gig. Is that a slot replacement, or are you supporting the 10 to 40 gig aggregating transceivers?
So the 40 gig is a separate 12-port QSFP line card. The 48 port is a 48 port 10 gig.
Yeah.
Today we don't support the ability to take the QSPs and break out the 4 different 10 gigs, but we will in the future.
Okay.
Any other questions? So goal here is allow people to scale. You can start off with just maybe a couple of the devices, and then in the future scale to higher numbers of devices within your Ethernet fabric and higher numbers of ports within your fabric. So now I want to talk about that ASIC technology because there's been a lot of talk in the market that a lot of the things that you can do today you can do with just merchant silicon, and I don't think that's true. There's some good things that you can do with just merchant silicon. Just go and buy it off the shelf. But our ASIC and the design that we've done with our ASIC has allowed us to achieve all of these remarkable numbers that I've been talking about, whether it's the low latency, the ability to scale, the ability to do all of this high performance interconnect and have the reliability that I was talking about, the ability to do the 8 ports of frame spraying across your ISLs. That's all built into our ASIC, and that's unique to Brocade. Is there a question?
I love the term frame spray.
You've that's a new rage right now on Twitter, frame spray.
Frame
Okay.
spray. We'll get it trending.
It's almost, yeah, 2 more.
Good. Brocade trunks frame spray.
Make sure you spray your frames.
Yeah, spray your frames. Oh, you guys are gonna get me in trouble. My wife is watching.
Hi, honey. Hi.
It'd be excellent.
you say future-proofed, does that imply that VXLAN is not terminated in, you guys don't do VXLAN currently
So
on this?
VXLAN currently no, but it is on our roadmap to support VXLAN. And let's see if I'm gonna get
Software
with
or
this.
ASIC?
The hardware.
The hardware is
still
capable of
getting
doing
ported, We haven't enabled the software yet, that'll be
Right.
coming in the spring.
Okay, cool.
But I will talk about that a little bit more in the roadmap. So also, you can see here, from a lossless capability standpoint, we can create a management fabric here that allows you to have all the lossless, well, was I that bad? Have all the lossless capabilities that you need within this type of network. Like I said earlier, low latency, 3.6 microseconds. From a latency standpoint, there are not many devices that can give you that type of latency within an Ethernet network in a chassis-based system. That's any port to any port, whether you're doing layer 2 or layer 3 on the device. We do our layer 2 and layer 3 lookups simultaneously on the device, so that's one of the ways we can get this low latency. And we support all the traditional QoS, 8 levels of QoS and priority flow control on the device. So, finding a good balance of having an ASIC that's flexible enough to enable new types of features like VXLAN and then also have low latency is not easy, but our guys have done a great job at doing that. So VXLAN wasn't a thought when we were designing this product, but there's enough table space in there to support VXLAN in the future just by doing some software enhancements. So get into the roadmap and talk a little bit about what we're going to do from a future standpoint. So what I've been talking about here has primarily been around a fabric within a single data center. What we want to do moving forward is give you capabilities that extend across data centers. And I'm not just talking about the VXLAN capabilities where you're encapsulating layer 2 within layer 3, but actually extending the intelligence with a fabric across data centers by leveraging some very unique devices that we're going to be bringing to market. So we'll be extending the fabric. I mentioned earlier this service-oriented fabric concept. The service-oriented fabric concept was layer 3 now. Where we're going to be going in the future is allowing you to do multi-tenancy type of functionality, so VRF-like type of functionality within the fabric. So now that you can have overlapping IPs, higher numbers of VLANs supported with the fabric.
We'll throw the question out there. VR Lite's nice, minimum barrier to entry. When will you support MPLS so you can have more carrier adoption in this?
So MPLS is done on our core product line. What are the types of things you want to do with MPLS? Because like some of the things that I see my customers who are bringing MPLS internal to the network without any of this technology is some customers I'm talking to who have brought MPLS internal to the network to get some of the traffic engineering benefits of MPLS. A lot of that can be achieved. Some of the things they want to do can be achieved with the fabric, giving them the low latency, separating things out, and then still having a simple, simple network and having the complexity in the core.
So absolutely traffic steering, but when I think about, especially in the context of a carrier, not really MPLS in the enterprise, but the ability to maintain simplicity in my provider backplane, right? Anytime I have to pop a tag higher up in the network, it's
I do want to be clear about one thing. There was some confusion when we first launched it, just because it is so big.
Yeah.
A lot of people assume this is a core switch. It was not intended ever in any way, shape, or form to be a core switch, right? The whole notion of the VCS architecture is it's a core edge architecture. So the idea is that you want to keep all of your switching as close to your compute as possible, right? You're dealing with a lot of server-to-server traffic in your data center. That's where fabrics really shine. So we've tried to keep all of our fabrics, designed essentially for access and to some degree aggregation, leaving the core basically untouched. So you're actually preserving your core investments there and offloading the core and not getting as much traffic going through your core.
okay.
Does that make sense?
Yeah, to a point. It still comes back to, I think there's a larger discussion, where should you pop a tag in the context of a service provider, right? Used to be you pop it as close to your client as possible, and now your client may be living very close to that service layer or to the server layer at the edge. Is it appropriate to pop in a map into a VXVLAN higher up? So I think this is I don't know if we're there yet. It'd be interesting to see where Brocade's take on that is, of how do you seamlessly extend a service provider network to the tenant in that multi-tenant cloud.
Right, I think that story is being still developed, but also the tenant is all over the place even within your data center because of these new virtualization models. So the tenant says, give me some more resources, and those resources go wherever they're available within the data center. So now they need that layer 2 domain to communicate with each other. So I think keeping the complexity in the core helps in that model, and you're mapping that VLAN off to the your core routing infrastructure or to whatever MPLS that goes back to their network. I think that is very helpful when you're not sure where these different virtual machines or virtual environments are going to fall.
Yeah.
But like I said, story's still materializing. But on the roadmap, what we're doing is this is a family of products and functionality that's going to continue to evolve. And so we talked about 20-foot port and 60 port, 10 gigs, and the chassis with 10 gig and 40 gig support. There will be higher density 10 gig devices, so there'll be a 1U device with higher density on it with 40 gig uplink. So if you want a top of rack with higher density 10 gig that gives you 40 gig into the spine, so leaf spine type of scenario, we'll have that available based on the same type of technology. Also, higher density 40 gig. So if you want a 2U device with a lot of 40 gig on it with high speed uplinks off into the spine, we'll have that for you. 10 gig base T. A lot of customers are asking for a roadmap to 10 gig base T. We're going to support that in our platform, both in a stackable and a chassis-based flavor of that. So whether they want to do an end-of-row type of deployment or they want to do a top-of-rack type of deployment, they'll have the ability to do 10 gig base T. And we're also moving to, on the top-of-rack devices, a flex port type model, where based on the optic that you put into the product, that will determine whether it's 10 gig Ethernet or 16 gig fiber channel. And that way you'll be able to do convergence very well within your top of rack for if you have those type of requirements. That's on the hardware side. On the software side, like I said, it's this whole service-oriented fabric model where we're going to enable things like multi-tenancy, enable you to also extend your fabrics across data center and have the ability to do virtual host mobility at distance. And so without worrying about that 5 millisecond window that you're allowed to do live virtual host mobility, you will be able to actually proxy that communication so you can do it at distance. So that's in the near future. You'll hear a lot more about those capabilities. And also, we support a concept of automatic migration of port profiles today within our fabric, meaning that when you create a port profile with the QoS settings and the VLAN settings of a virtual host, and that virtual host moves within that fabric, that port profile goes with them. You don't have to go to the other switch and reconfigure it. So since that moves within the fabric, what we want to allow you to do that is extend that between the fabrics without merging the fabrics together. And so we're going to be leveraging some of our extension capabilities we already have on the SAN side, bringing them over to the Ethernet side to give you some of this capability. Make sense? You liking what you're hearing? Is this the right direction?
That's the right direction.
Oh, okay, good.
I didn't see that part at the field at the analyst day. You didn't talk about futures there.
Yeah.
Excuse me? Which one?
We didn't talk about futures at the tech day.
Oh, okay.
Last month.
I mean,
Again, legal disclaimer, please don't sue.
We're only streaming this on the internet, so please don't.
But I mean, those are features that you need to develop. You've got your brand new platform out. That's the rolling software release over the next, and they're the features that you're going to bring out, which is, they're predictable, really.
Well, that's why I covered the interconnect first. We want to give you a solid foundation we can grow on, and then we can start growing all these other features on it. And that also gives you a clearly differentiates us from our competitors out there and how they do things.
Mm-hmm.
We have a whole different mindset on how we're going to do these things, but we know it has to be on a foundation that can support it.
Yeah.
And we think we have a good foundation, and now we can start going out and exploring these things like VXLAN and other type of functionality, or giving you alternatives to VXLAN. We're not saying you have to do VXLAN. We will support it, but we also will give you alternatives to VXLAN with a layer 2 extension capability between data centers that allows you to do live migration, which we think will be valuable to a lot of our customers.
So we'll be talking a lot more about that later this afternoon as well.
More details. So just touching on the VXLAN. VXLAN is hot right now, so of course we have to talk about it. What it allows you to do is that, layer 2 encapsulating an IP. We want to make sure you have visibility into that. So the platform has its has the ability to support it in hardware. We're just going to enable it in software. You'll have full visibility of the VXLAN. We also, within our platforms, will allow you to terminate VXLAN in the devices. And like I said, later this afternoon, like Lisa said, we'll allow you to see some of the alternatives to VXLAN in the future.